Okay, time for week 10, homework number 2. And this homework assignment's a little different because it's split into 2 separate parts that don't mix. And so I'm going to actually make a video for each part. So the first part is the fundamental theorem of calculus, but they call it part 1. And then when you finish that, then we'll move on to part 2. And there's basically just 3 kind of problems. They're actually all the same, but they're set up just a little bit different. So the first kind has the upper bound as a function and then the lower bound as a constant. The second has the upper bound as a constant and the lower bound as a function. And then the third has functions for both. And so they all work just a little bit differently, but very, very similar. So what they're asking you to do here is to find the derivative, not the original function, but the derivative. So what that means is you're not actually finding the antiderivative. So you're not actually going to be doing that much work. What this wants to make sure that you understand is that this is the derivative. Okay, whenever you have the integral sign, this is the derivative. So when it says find the derivative, they basically give it to you. We just need to plug in that little function. So since we're plugging in e to the x, we're going to plug that right here in for that letter t. And so that would become e to the 3 x, and then you would just keep that minus 2. And then the only other thing that you have to remember is that since you're plugging a function into the derivative, that the chain rule does apply. So then we're going to multiply that by whatever the derivative of e to the x is, which is just e to the x. And then you would stop there. That would be your answer, and you would be done. Technically, because this is a constant, there's like a plus 0 right there, but we just don't usually write that. So when you take the derivative of a constant, remember it's 0. So we just don't usually put that at all, but it's kind of there. And so then the same thing happens here. Technically, you're plugging in a constant, and so that's going to have a derivative of 0. So I mean, I guess technically, when you're finding the derivative, it does have a 0 first, and then plus, and then we're going to plug an x into this function. And so that's going to be the square root of 2x minus 2. And then we have to take the derivative of x, which that one's pretty easy. The derivative of x is just 1. But you have to remember that when you're finding upper and lower bound, you do the upper minus the lower. So there does need to be a negative sign somewhere. A lot of times I just multiply it by whatever the derivative of that was and make it negative. So I would probably just multiply that one by a -1. And then when I type my answer into Newton, then I'd probably not put the 0 and I'd just do negative the square root of 2x minus 2 would probably be a good answer. Okay, and then you get to the last part, which is just combining those, and that is you have a function and then a function, and remember it's the first one, and then plus, and then a negative of the second one. And Newton will actually mark it wrong if you don't put that plus in the middle. And so I didn't have much luck trying to skip that step. So going through the steps again, we're going to do the upper bound first, and we're going to plug that into there. So that would be x to the 4th to the 4th. So that would be x to the 16th, and then you're just going to keep that -3 all to the 6th power. And then the chain rule, you have to take the derivative of that, which would be 4x cubed. And then plus, and then we plug this in. And so 2x all to the 4th is 16x to the 4th minus 3 all to the 6th. And then the derivative of that's just 2, but you need a negative, okay, because lower bound, you're subtracting or taking a negative. And you could rewrite that a little bit if you wanted to move this to the front or move to the, but that's fine, just the way it is. That's probably how I would leave that answer. And so you're going to get to that part in the assignment, and that's going to be all the fundamental theorem of calculus, part 1. And we'll do part 2 next. Hope that helps.